Okay, section 1.5, complex numbers. So we're looking at imaginary numbers, guys. So you know that by definition, I equals the square root of -1. And that would mean if you squared both sides, I squared would equal -1. So complex numbers are any number in the form of a plus bi. If b were 0, then you would have a real number because it would be like 3 plus 0i. If a is 0, then you have what's called a pure imaginary number, really because it would be like 0 plus 7i if we were to ask you to write it in a plus bi form. And therefore, all numbers, real and imaginary, are complex. Okay. Just note that in our Orange workbook, when the word complex is used, it refers to imaginary numbers. Okay. That's for us going forward. All right, so then two complex numbers, a plus bi and c plus di, are equal to each other if and only if. No, this is not a typo. Okay, that means if and only if a equals c and b equals d, right? Because the real part has to equal the real part and the imaginary part has to equal the imaginary part. I highly doubt you would tell me that just make up anything. 2 plus 3i. I don't think you would tell me that that equals 5 plus 6i, right? Because 2 doesn't equal 5 and 3 doesn't equal 6. Okay, so for example, if a plus bi equals 13 plus 4i, then again, just kind of equating those different parts, you would know that a would equal 13, and you would know that b would equal 4. Okay. All right, in a complex number, a plus bi, the a term is what's called the real part, and the b is the imaginary part. So keep that in mind. I'll start asking you that in some of our examples. Okay. All right, little exploration. See if we can come up with some patterns. So I to the first, anything to the first is itself. And like we just said, I squared by definition is -1. Well, I cubed, if you think about creating it in case you're like on a test or something and you forget it, I really want you to have these memorized. But remember, I is really I times I squared. Okay, that would give us I cubed. And since I'm writing it, let's go ahead and make a note here, guys. We need to make sure that I can tell a big difference between your ones and your i's. So let's make sure that you're curling it, okay, kind of like I'm doing. So curl it and dot it. Okay, so I'll say curl and dot your i's. All right, I think that will help us. All right, so back to I cubed, and then I times I squared equals I cubed. And therefore, if you just take the results from above, if you took the I times -1, you would get -i. Okay, now think about how you could get I to the fourth. You could do I squared times I squared, right? Because you multiply like bases, you add exponents. And I squared is -1 times -1 would give us +1. Your other option is I cubed times I, okay? But whatever makes it the simplest. If you keep going, I to the fifth then, well, I to the fifth would be I to the fourth times I, and I to the fourth is 1. All right, so if you start looking, you're going to see that you've got I here. Figure out I to the sixth, however you want to do that, I to the fifth times I, or whatever works for you. I squared times I to the fourth, that's probably the easiest one. You'll get -1. I to the seventh would be -i. I to the eighth would be 1. Right? I to the ninth would be I to the 10th is -1. I to the 11th is -i. And I to the 12th is 1. So if you go down those columns, I hope you're noticing that there is definitely a pattern. Okay, I, -1, negative I1, I, -1, negative I1. So that's your pattern. And obviously, math is a lot about patterns. We want you to notice those patterns so that on the test, if I ask you to find like I to the millionth power or to the millionth 293rd, whatever I have to do to make you show me some work, okay? Obviously, we don't want you to count it out a million times. We want you to come up with a pattern. The nice pattern that I'm seeing is that every fourth one is 1. And by that I mean this. I to the 4th is 1. I to the 8th is 1. I to the 12th is 1. Okay, so I like 1. That's an easy number to deal with. So if I was asking you how to find what I to the 47th is, then really all I need to have memorized is I to the 1st through I to the 4th. Okay, because I'm going to say that I to the 47th is equal to I to the 4th, which is 1, we know in a minute, but I'm really just doing powers, right? I'm doing the exponents that we've done and we've mastered in this year so far. So 4 goes into 47 11 times, because power to power you multiply. That would get us I to the 44th. And then you need to multiply it by I to the, from 44 to 47 is 3 left, because when you multiply like bases, you add the exponents. So that should be I to the 47th to you, if you think about that. And then I to the 4th is 1. So 1 to the 11th power is really what's sitting there, times I cubed. And now that means all I have to have memorized is what I cubed is, okay? Or go back and create it if I can't remember. So this is really 1 times I cubed, which is I cubed, and then you'll tell me that that equals negative I. And there's your final answer. Okay? All right, so make sure that if we're giving you any I problems where you've got powers greater than 4, that's the work that you're showing. All right? Next, using examples using imaginary numbers. Okay, let's talk about some notation first so we don't run into any issues. So first things first, never write something like this, 2 root 3i. Okay, so what we're targeting right now is when you have roots with i's. Okay, roots with i's. So understand that if somebody's typing it, okay, just like we put in our answer key, you'll probably see it typed that way, because 2 root 3 is the number in front of I. However, when you're doing this handwritten, guys, it would be an issue if you were writing very quickly and you wrote that. There's a difference between the I being under the root and not being under the root. So the way to avoid this issue, okay, is that we always write, we'll say instead, write this. So when you're handwriting it, you always put the I in front of the root. Okay, so 2I root 3. It's still understood that the number in front of I, the imaginary part, if you will, is 2 root 3, but that's just notation. So when I'm seeing you handwrite it and when you answer it like on a quiz or a test, I should always see your I in front of your roots. Okay, so we don't have any of that issue. Next, you need to realize that this is sort of like an order of operations, okay? So you'll hear me say this kind of lingo, and I will say, always take your I out first. Sounds a little dangerous, but we're talking about the imaginary I, not your I. So always take your I out first. Okay, and you'll see how it makes a difference. Okay, so here we go. Number 1, I need you to think of this as a square root of -1 times 12. And then the square root of -1 is the I. So you're left with I root 12. That's the order when we say always take your I out first that we're talking about. Has to work for you guys to get it correct. And then however you break down root 12 for yourself, you should be good at that by now. Root 12 is 2 root 3, so this is where 2I root 3 would be written. Okay, and if I'm just practicing, if I ask you for the real part to this answer, you would tell me 0. And if I ask you for the imaginary part to this, remember imaginary part's just what's in front of the I, it would just be 2 root 3. Okay. All right, try that second one for yourself. So the negative's hanging out front. I need to at least think of this as negative 1 times 9 inside the root. So this is negative. The square root of the negative 1 is going to become I, root 9. Okay. Square root of 9 is 3. So we're going to get negative 3i. There's your final answer. The real part of this would be, think about if it said a plus bi form, what would the real part be? Well, there is nothing, so it would have to be 0. The imaginary part, the number in front of I, would be negative 3. Okay. All right, number 3, if I was asking you to solve for x, okay, we've done that one a few times. I'm probably thinking extracting square roots, right? So I'll move the negative 4 to the other side. So if x squared equals negative, and I then take the square root of both sides. Okay, now when we weren't doing imaginary numbers, right there we were saying we were stuck, right? Because we can't take the square root of negative numbers. Well, we can when we have imaginary numbers. So now this is x equals, ooh, don't forget that important thing. If you've put in the square root, it's got to be plus or minus. Okay, it has to be there. And it's going to be plus or minus the square root of negative 4. So now think about those steps. Don't do it too fast. It'd be plus or minus. The thinking needs to be negative 1 times 4. So that the square root of the negative 1 is the I, and the square root of 4 is the 2. So there's your plus or minus 2i. Okay. All right. And then solving for x. Now, we've talked about this several times, right? As far as it's a quadratic, what are my different ways for solving for a quadratic? So the very first thing you should always be trying, factoring. Okay. If you try to factor that guy, you'll find it doesn't factor. Okay. So your next thing always should be quadratic formula. So if we go ahead and walk through quadratic formula with this one, okay, let's get us a little more room here. All right, so we'd have, well, up to you if you're going to do this part. A equals 3, B equals negative 2, C equals 5. All right, I'm ready. X equals the opposite of B plus or minus the square root of B squared. So negative 2 in parentheses squared. Minus 4 times A of 3 times C of 5 all over 2 times A of 3. All right, so we're looking at 2 plus or minus. That first number better be positive. It is a 4. And then negative times positive will be negative. 4 times 3 is 12. 12 times 5 is 60. All over 6. All right, so 2 plus or minus the square root of negative 56 all over 6. And now, since we're in the complex chapter, we're going to think of that as negative 1 times 56. Break down your 56. Square root of 56 would be root 14. Okay, because it's 4 times 14. All right, for 56. So we've got 2 plus or minus. Don't do too many steps at once if you can't get this right. So 2i root 14. That's what should be there, over 6. And at this point, if you go back and circle what you're looking at, you've kind of got these 3 numbers that you're always looking at to see if they reduce by the same number. Okay, so if you're looking at all 3 of those, they all do reduce by 2. And so 2 divided by 2 is 1, plus or minus. We don't write a 1 in front of something, so it's just 1i. We just write the I, root 14, all over. 2 goes into 6 3 times. And there would be your 2 answers, right? Since it is quadratic. 1 minus I root 14 over 3 and 1 plus I root 14 over 3. All right. Let's talk about some operations with complex numbers. I don't think there's really anything you need to memorize here. I think you'll probably find it pretty logical if you will just combine like terms. But if you really want to memorize something, addition and subtraction, you're just adding and subtracting the real part and the imaginary parts separately. Okay, so addition and subtraction work in that way if you want to look at that. But let's just do some examples. I think you'll find them to be pretty straightforward. And then I'm going to practice with you. Let's say answer in A plus BI form. Answer in A plus BI form. Okay, so here we go. I'm going to first just say 3 plus 2i. I don't need parentheses. I'll go ahead and distribute that negative sign here. So negative 6 minus 13i. Combine like terms. And I'm thinking I want an A plus BI form. So the real part, 3 minus 6 is negative 3. And minus what, 11i? There you go. So just verbally, what's the real part? Negative 3. What's the imaginary part? Negative 11. Okay. Number 6. All right, well, this one looks a little more daunting. Let's see what happens though. So I've got 7i plus 8. Take the time to break that one down. Hopefully you're thinking of that as negative 1 times 18. And 18 is really 9 times 2, so 3 root 2. And of course the negative has to have an I, so plus 3i root 2, if you're writing the notation correctly. All right, well, we asked you to write this in A plus BI form. And hopefully you agree that these are not like terms, okay? Or I should say those two are the like terms, but because they both have an I in front of them, but they are not like terms in the fact that they're going to add together, right? Just like a 7 and a plus a root 2 don't go together. It ends up 7 plus root 2. But let's go ahead and get it in the right form. So we asked you for it to be in A plus BI form. So the A part being the 8 plus, well, if I have to have it in BI form, that means I've got to factor an I out of those other two terms. So if I take an I out, I'll have 7 plus 3 root 2. There you see the different terms that would not add together. And the I goes at the back because that would be A plus BI form. So what would the real part be? It would be 8. What would the imaginary part be? It would be 7 plus 3 root 2. Okay. All right. And then multiplication. Just multiply using distributive property. Okay, if you know that as FOIL, we're always going to use the word distributive property, just like you would with real numbers. Okay, nothing's going to change. So here you go. If you're distributing the 2 to the 5, you get the 10. And the 2 to the negative 4 would be negative 8i. Likewise, if you're going to go with 3i times 5, you'll have plus 15i. And carefully, 3i times negative 4i would be negative 12i squared. Okay, now you're just into the simplification mode. So 10 minus 8i plus 15i. I'm always just going to target my I squared. Remember, I squared equals negative 1, and negative 1 times negative 12 would turn that into positive 12. Okay, I'm ready to combine like terms then. So 10 and 12 will be 22, and 15 minus 8 will give me, I guess, 7. So 22 plus 7i. What is the real part? 22. What is the imaginary part? 7. Okay. All right, in 8, hopefully you're remembering that if you see something in that form, that means multiply it by itself. So I would write it out twice. And then go ahead and do that distributing. So 2 times 2 is 4. 2 times negative 3i is negative 6i. Distributing the negative 3i then times 2 is going to be again negative 6i. And negative 3i times negative 3i will be plus 9i squared. Okay, so once again, just so you can see my steps, I'll leave those first 3 alone. And my I squared is negative 1 times 9 is negative 9. Combining like terms then, I've got 4 minus 9 is negative 5, and negative 6 and negative 6 would be negative 12i. So what is the real part? Negative 5. The imaginary part? Negative 12. Okay, I just want you to be familiar with that wording. Okay, we will ask you that in the homework and stuff. All right, so with all that practice, I just need to make sure that you are being totally careful, guys. You must use the I form for complex numbers. And by that, that's what I say when I say don't forget to take your I out first. Okay? Otherwise, you will start having these issues. Okay? On the left, we know that roots can multiply by each other, right? So we might be inclined to say that root negative 2 times root negative 8 would be root 16, and the square root of 16 is 4, right? Big no. Okay, and we'll prove it to you next. So what you need to notice on the right-hand side, guys, is if you use the I form or take the I out first, well then think about what would happen to this. Okay, on the first step, you would have the I come out of each one of them. And then if you multiply each of those together, I times I is going to give you I squared. And now root 2 times root 8 is root 16. I squared by definition is negative 1. Square root of 16 is 4. And negative 1 times 4 is negative 4. So notice, you do not get what you logically would have thought if you don't kind of do that sort of order of operations correctly. Okay, so keep that in mind. For division, multiply the numerator and denominator by the conjugate of the denominator. And we've talked about conjugates before, right, when we had roots. So if it was like square root of x plus square root of y, then the conjugate was root x minus root y, just changing the sign. This one's just what's called the complex conjugate because it's got imaginaries in it. So the conjugate of a plus bi is just a minus bi. Change the sign on the imaginary part. Okay, so here we go. This is about rationalizing and so on and so forth, because in this example, number 9, you should recognize that as if I is in the denominator and I is a square root, right? Square root of negative 1, well, I can't have roots in the denominator. Okay, so I need to rationalize it. So we've got options, guys. You do have other things that would work for this. But here's what I'm going to say. And this is just from probably doing this enough times for you guys to get comfortable. So if we take negative 10 over 2i and I multiply by I over I, can't change the problem, right? But if I multiply by I over I and I multiply straight across, I'll have negative 10i over 2i squared. Okay, and I desire to have I squareds because I know that this is now negative 10i, and I squared just turns it into a negative. Negative 1 times 2 is negative 2. And now I don't have any roots in the denominator. The last thing I need to do is just simplify, right? So negative 10 over negative 2 is 5. So 5i is what looks like is happening here. Now, if I was forcing you, if I was still saying follow the directions, which we might do on the quiz, and I was saying put it in a plus bi form, well, then make sure that you answer 0 plus 5i. Okay, so if I was asking you for putting it in a plus bi form, then make sure that you answer that. Okay, all right, on number 10, this is what we're talking about. If you see two terms, right, in the denominator, then multiply by the complex conjugate. So I'm just going to move it over here so we have a little more room. So let's do 3 over our 1 minus I, and I'm going to multiply it by the conjugate of the denominator, so 1 plus I. Whatever you do to the denominator, you got to do to the numerator, so you're not changing it. Put some parentheses in here because that's what's really happening now. And if you multiply straight across, I'll decide if I'm going to distribute that 3 into the top later. Remember, my goal is usually factor things out and try to have things cancel. So for right now, I'm just going to let it hang out front. So 3 times that quantity, 1 plus I, over, carefully distribute on the bottom. 1 times 1 will give you 1. I hope you're looking at that sort of like difference of perfect squares. The 1 times the I and the negative 1 times the I are going to cancel the outer and inner terms. So 1 times I and negative I times 1 will cancel, and you're left with just the negative I times the I, which is negative I squared. Okay, try that for yourself if you need to look at that for a moment. And then 3 times 1 plus I over, well, 1 minus, since I squared is negative 1, I have now gotten rid of the roots, okay, like I'm supposed to, in the denominator. I still have the 3 times 1 plus I, and now this is really 1 minus minus turns into plus, so it's really 2. Okay. All right. So far, doesn't look like anything's going to cancel. So I might as well put that 3 to the top. So if I distribute that in, I'll have 3 plus 3i all over 2. And then since I'm supposed to put this in a plus bi form, okay, you need to be able to do this in reverse, okay, of getting a common denominator. You should realize that that's really the same as 3 halves plus 3 halves times I. Make sure it looks like it's times I and not divided by I. So there would be your final answer if I was asking it for in a plus bi form. Okay, which they like to do a lot. So just pay attention to that. Again, what's the real part? 3 halves. What's the imaginary part? 3 halves also. Okay. All right, maybe you want to try this one on your own and see what happens. All right, so I'm taking the 8 minus 7i over 1 minus 2i, and I'm going to multiply by the conjugate of the denominator. 1 plus 2i. 1 plus 2i. Okay, you need a bunch of parentheses just so you're distributing correctly. Carefully see what you get there. I'm going to get 8 plus 16i minus 7i minus 14i squared over 1 plus 2i and minus 2i will drop out, so minus 4i squared. That's the whole point of multiplying by the conjugate. Outer and inner will always drop out. And then looks like I would be sitting at combining like terms. Maybe I'll wait on that for a moment till I tackle my I squared. So I squared being negative 1 times the negative 14 will be plus 14. And in the bottom, I'm really going to have 1 plus 4 for the same reason, right? I squared is negative 1 times the negative 4. All right, now we can combine like terms. So looks like I am looking at 8 and 14. So 22 and plus 9i all over 5. And then just go ahead and get it in the right format, okay, if we're asking for a plus bi form. So that will equal 22 over 5 plus 9 over 5 times I. Okay. Once again, that's in your a plus BI form. Okay, there would be our final answer. And like it says in the note, guys, in standard form, a complex number is written with the real part and the imaginary part being separate, which is what we've been practicing all the way through. Okay, so continue to practice with that and see what you can do.